It is here, at the Agropole site in Molondin, that Medusoil has been producing its biocement since 2024. It all started with the co-founder of the company, Dimitri Osterzis, also a researcher at EPFL, who identified microorganisms in the soil with astonishing properties.
It's inspired by a natural process. We isolated endemic microorganisms from the soil. We selected 50 strains in an agricultural area of Ticino that are most inclined to make the natural biocement, which is actually calcite. So these strains are capable of producing calcite that will associate with soil elements and create a natural soil reinforcement.
Through a natural process, Medusoil produces 500,000 liters of this biobinder per year.
We will culture the microorganisms, and much like an agro-food fermentation process, we will provide them with all the necessary nutrients so that they develop, and by the end of the process, which lasts about 48 hours, we have all the minerals needed for the next step of the process.
The element that acts as a binder in this biocement is calcite, a mineral material naturally present in the soil, which makes it much more ecological than traditional cement.
A traditional cement, emits a lot of CO2 during its production because it requires a clinkering reaction that takes place in a kiln heated to 1450 degrees, whereas we, on the contrary, use bioreactors where the temperature is maintained at 35 degrees. So obviously, in terms of CO2 emissions, it's not comparable at all. Beyond climate protection, we also focus on the protection of ecosystems and the environment. For example, we have had our products analyzed for their ecotoxicity, and we have been able to demonstrate that they have no ecotoxic impact. So the microorganisms and living organisms in the soil are not affected by treatment with our products. And finally, when we talk about sustainability and circularity, it's important to overcome the issue of waste. And for us, both in terms of manufacturing and application, we are zero waste.
Biocement can be used to reinforce soils in various scenarios, especially in natural areas or sensitive environments.
Wherever there is a need to reinforce a soil, biocementation can be applied. This includes, for example, the reinforcement of dikes to combat the risk of erosion. It also involves the treatment of clay soils to, for instance, prevent the shrink-swell phenomenon of clays, which causes cracks in roads or houses. We can also stabilize slopes to reduce the risk of landslides.
Biocement is not about to replace traditional cement, as it cannot be used for structural constructions such as buildings. However, by reinforcing the soil, it allows for lighter foundations.